Hello, hello, Shagatanon here. Welcome to another Rust coding stream here on the 2nd of January, 2023, local time 9:49. And started a few minutes early here instead of 10 o'clock because it seems like it's going to storm today and I got to go get groceries and stuff. So if things work out the way it looks like, I'll be able to finish this and have enough time to take care of it. So yeah, let's go ahead and not waste too much time here. Oh, whoops. Yeah, we already generated the map. The quick version is we finished what looks to be like the rest of the main map generation stuff last time. We have some cool layering going on where we can generate a map with one algorithm, and then we may or may not add like a fortification to it. In this case, we're doing wave function collapse on it, which is pretty cool. I was going to call that out. So it's another thing we can do. There's a lot of things we can kind of chain together. And this time, we're going to want to actually do a lot of refactoring. This is a horrible map. Are we going to throw this away? Nope. Yeah, we need some heuristics for that. I'll talk about that in a moment. 1 second. I got to sneeze. All right, hopefully that's that. Maybe feel a third one, though. Not sure why it always happens when I start streaming. It's like I haven't sneezed at all today, and now it happens. Alrighty. So we're going to take a look here at the browser. As I was trying to say, we're going to be doing some like builder chaining and stuff here. That's going to allow us much better control over how we build our maps and how we layer things together. This is going to be using something called a builder pattern, which generally with the builder pattern, you make some kind of a builder, go figure, and then you can tell it what you want to build the thing with. And then when you're done, you ask it to build the thing. So an example is I was dealing with an API once with a REST API online, and I needed to make a request, but there are a lot of optional fields and stuff. So what I could do is I ended up making a request builder for that particular REST API, and it takes in the required information that it needs, the minimum required information. And then you can do, with that builder, you can keep chaining function calls on it, and you can say, all right, I have a builder with this basic information, now dot with an additional thing, dot with another additional thing, dot with maximum number of results, dot with sorted by, you know, whatever sorting we do, whatever. You could keep doing dot with and adding things that you want in that request. And in the end, you say, you know, build request or get, you know, actually perform the request, right? So that's an example of the kind of thing it looks like we're going to be doing with the map system now. So let's get started. The last few chapters have introduced an important concept in procedural generation, chained builders. We're happily building a map, calling wave function collapse to mutate the map, calling our prefab builder to change it again, and so on. This chapter will formalize this process a bit, expand upon it, and leave you with a framework that lets you clearly build new maps by chaining them together, by chaining concepts together. So we're going to need a builder-based interface. So builder chaining is a pretty profound approach to procedurally generating maps and gives us an opportunity to clean up a lot of the code we've built thus far. We want an interface similar to the way we built entities with specs, a builder onto which we can keep chaining builders and return it as an executor, ready to build the maps. We also want to stop builders from doing more than one thing. They should do one thing and do that well. That's a good principle of design. It makes debugging easier and reduces duplication. There are two major types of builders: those that just make a map and only make sense to run once, and those that modify an existing map. So we'll name those initial map builder and meta map builder respectively. It gives us an idea of the syntax we want to employ. The builder should have one initial builder and meta builders that run in order. It makes sense then that the builder should have a start with method that accepts the first map and additional with methods to chain builders. The builders should be stored in a container that preserves the order in which they were added. a vector being the obvious choice. It would also make sense to no longer make individual builders responsible for setting up their predecessors. Ideally, a builder shouldn't have to know anything about the process beyond what it does. So we need to abstract the process and support snapshotting so you can view your procedural generation progress along the way. So we're going to do shared map state, the builder map. Rather than each builder defining their own copies of shared data, it would make sense to put the shared data in one place and pass it around the chain as needed. So we'll start by defining some new structures and interfaces. So first of all, we're going to make builder map in our map builders mod.rs. So let's get over there and do it. I'm going to pump this up one time. And we're in the mod.rs already. So here at the top we have map builder. Now we're going to have builder map. And that naming could get a little confusing depending on how you use it, so be careful with names like that. So we should recognize that usize string tuple. We've been doing that for a spawn list all along. All right, so we have this builder map, spawn list with a map, a starting position, rooms, and history. I think that looks a little bit familiar because pretty much everything that we did map builder with had all of that kind of information. If we were to go take a look at, say, BSP Dungeon Builder, map, starting position, depth, rooms, history, rects, which would be not quite rooms in this case. We have rooms, but this is how we broke down and did the BSP algorithm, if you recall. We have the spawn list. We're gonna notice that what we just defined is very similar to that, and pretty much all of them are very similar. So I recognize this, and you know that's going to be part of abstracting it, as we've already said. So as the tutorial text says, you'll notice this has all the data we've been building into each map builder and nothing else. It's intentionally generic. We'll be passing it to builders and letting them work on it. Notice that all the fields are public. That's because we're passing it around, and there's a good chance that anything that touches it will need to access any or all of its contents. The builder map also needs to facilitate the task of taking snapshots for debugger viewing of maps as we work on algorithms. We're going to put one function into builder map to handle snapshotting development. So we need an impl block for that. Impl builder map. Take snapshot. If show mapgen visualizer, then we're going to do let mute snapshot self.map.clone, and then for v in snapshot.revealed tiles.itermute, set them to true. We could do that with iterators, by the way. You don't have to do it with a for loop. It's fine in this case. It's pretty simple, but other options, it's always interesting to note. It feels a little more functional if you do it with iterators. But I'm not going to waste time on it. So this is the same as the take snapshot code we've been mixing into our builders. So if we're using a central repository of map building knowledge, we could promote it to apply to all of our builders. Now, the builder chain, master builder to manage map creation. So previously we've passed map builder classes around. Still get the lag, sorry. We've passed them around, each capable of building previous maps. Since we've concluded that this is a poor idea and defined the syntax we want, we'll make a replacement. The builder chain is a master builder. It controls the whole build process. To this end, we'll add the builder chain type. So we'll just come right down here. So this is something we don't have yet, but we'll see it in just a moment. And same for that. So yeah, we're going to see a little bit of anger here because we don't have an initial map builder or a meta map builder. Now, I think we've talked about it before in this tutorial, but just in case we haven't, the errors are giving us a little bit of help already. When we do dine like this, we're specifying like a trait object, essentially. So we're saying anything that implements this trait, initial map builder, can go into this box. And then this is an option because we don't know if we're actually going to have one, which I find that interesting. What would we do without a starter? We'll see how that plays out. I don't think you would always have a starter, but we'll see how that plays out, as I said. So anything that implements initial map builder can go in here, and we have to box it up because different things can implement that trait that are different sizes. So we don't know what that size is going to be at runtime. So we need, or well, even at compile time, we don't know what that size is going to be. So boxing it up allows us to have an actual sized data type, the box, that we can work with. All right. So it's a more complicated structure, so let's go through it. Starter is an option, so we know if there is one. Not having a first step, a map that doesn't refer to other maps, would be an error condition, so we'll track it. We're referencing a new trait, initial map builder. We'll get to that in a moment. Builders is a vector of metamap builders, another new trait, and again, we'll get to it in a moment. These are builders that operate on the results of previous maps. Build data is a public variable. Anyone can read, write it. And it contains the builder map we just made. So we'll implement some functions to support it. First up, a constructor. So we have builder chain. Okay, let's go ahead and start working on that. So this is going to be in an impl block. Or I said builder chain, but impl builder chain. I was like, so we have builder chain. Of course we do. But I mean, we have an impl block for builder chain. And now for starter, it's going to be none. Builders is going to be vec new. Build data is going to be builder map. And I'm just going to copy this because I'm being a little lazy with it. We're just initializing spawn list as a new vec, map as a new map with the depth, starting position to none, rooms to none, and history to a new vec, an empty vec. Very simple. I don't feel like I need to type that out. So it's pretty. The text says it's pretty simple. It makes a new builder chain with default values for everything. So now let's permit our users to add a starting map to the chain. Starting map is a first step that doesn't require a previous map as input and results in a usable map structure, which we may then modify. So we're going to have this function here, pub function start with, and it's a mutable reference to self, starter. It's going to take an initial map builder. We're going to match on self.starter. In the none case, we're going to do that. We're going to put the starter in there. In the sum case, we're going to actually panic and say, hey, you can only have one starting builder. Maybe not the way I would do it, but if you treat your code right, then it's okay. I just get concerned about the game crashing when an error happens. I mean, that sometimes happens, but you want to prevent your game from crashing. So I think in a lot of cases, it's better to go to some default behavior that would be better than nothing. That's my philosophy on something like this. Something that's good enough to get you by. But it's simple enough, right? So the tutorial text, apparently we haven't talked about panic though. So this is pretty simple. Wrong one. There's one new concept in here, panic. If the user tries to add a second starting builder, will crash because that doesn't make any sense. You'd simply be overwriting your previous steps, which is a giant waste of time. We'll also permit the user to add meta builders. Okay. We'll pop in here and we'll do that one. And there we are. We simply push the meta builder into our list of builders. Very easy. We just take in a meta builder as an argument, and that's it. Not very much going with that. Pretty simple. And the text says as much. This is very simple. We simply add the meta builder to the builder vector. Since vectors remain in the order in which you add them, your operations will remain sorted appropriately. Finally, we'll implement a function to actually construct the map. So let's get to that one. So we'll take in a random number generator as a reference, and we're going to match on the starter. Oh wait, comma. Here. Some starter. All right, so simple enough here. I think to build map, we match on our starter, and then just one moment. Okay, sorry, I had to double check something. To build the map, we match on our starter, and then if there is none, we panic. If there is one, we do starter.build map. So that's pretty self-explanatory. But we have this build data, which we're passing in. So build data, again, was a builder map, right? And the builder map was the thing with the spawn list and map and starting position and rooms and history, right? So all that's getting passed along, and that's what's going to be used to build it, right? And that's going to keep track of everything, rather. So that's why we're mutating it. We're passing it along to mutate it. And then we do that for every meta builder, right? We run the meta builder. So there's a meta builder.build map. And we simply call the build data, or we simply pass the build data, into that when we call build map. So it can keep track of that same build data that we used here or in the previous iteration of the loop. So if we run 10 meta builders, we'll keep passing in the updated build data every time, right? So it's just keeping track of our changes. That's our map state. So we'll walk through the steps from the text here and say we match on our starting map. If there isn't one, we panic and crash the program with a message that you have to set a starting builder. We call build map on the starting map. And then for each meta builder, we call build map on it in the order specified. It's not a bad syntax. It should enable us to chain builders together and provide the required overview for constructing complicated layered maps. So new traits, we're going to have these two here, initial map builder and meta map builder. So we can also call them trait interfaces, they're calling them here. We're going to make them separate types so we could force the user to pick only one starting builder and not try to put any starting builders in the list of modification layers. So the implementation is going to be the same for both of them. It's going to be very simple to the point where I'm just going to copy it. But we'll read over the text. In fact, I don't know if we've really... It's been a while since we've defined a trait. I mean, we have the map builder. So yeah, we have been doing them. It's just been a while. So just to, refresh, it's just like a struct except pub trait. And then we're just specifying what functions are going to go into the trait rather than data. So in this case, both of them have a simple build map, which is what we just saw. It takes in a random number generator and a builder map, which is like our map state that's going to be tracked from call to call. So it's pretty straightforward. And the text says as much, it looks like. Build map takes a random number generator, so we stop creating new ones everywhere. And a mutable reference to the builder map we're working on. So instead of each builder optionally calling the previous one, we're passing along state as we work on it. So now the spawn function. We also want to implement our spawning system. And it's almost exactly the same as our previous spawn code, but instead we're spawning from the spawn list in our build data structure. Otherwise it's identical. So we'll type it anyway, but it's really simple. So we're going to do that on the on here on the builder chain. So it's going to be pub fn spawn entities. And we're going to take in the ECS because we need that for spawning, right? We'll iterate through the spawn list of the build data. And spawner, spawn entity, ECS, that was already there. And references to both pieces of the tuple. And that's basically it. Very easy. So random builder take one. So finally, we're going to modify random builder to use our simple map builder with some new types to break out the creation steps. So this is very different than what we've had before. So I'm going to get rid of everything in here, and we're going to type it out because it is different. It's using our new builder pattern, and it also takes in an RNG with a random number generator. And instead of returning the box dine map builder, we return the builder chain. And now we simply say let mute builder will builder chain new depth. So this is going to fail for the moment. Yeah, it's going to fail for the moment. It should. And simple map builder is mad because that new takes the depth and we're not currently passing it, but we're going to be modifying that. So like everything here is currently bad because we don't have the syntax. We don't have things ready to support it. We don't have the traits and everything in place. We don't have room-based spawner and stairs and stuff yet. So we'll get to that, right? So it says, notice that we're now taking a random number generator parameter. That's because we'd like to use the global RNG rather than keep making new ones. This way, if the caller sets a seed, it will apply to world generation. This is intended to be the topic of a future chapter. We're also now returning to a builder chain rather than we're returning a builder chain rather than a boxed trait. We're hiding the messy boxing dynamic dispatch inside the implementation, so the caller doesn't have to worry about it. There's also two new types here, room-based spawner and room-based starting position, as well as a changed constructor for simple map builder. It no longer accepts a depth parameter. We'll be looking at that in a second. But first, let's deal with the changes to the main program resulting from the new interface. Yeah, it says nice looking interface, but you broke stuff. So we now have the interface we want, a good map of how the system interacts with the world. Unfortunately, the world is still expecting the setup we had before, so we need to fix it. In main, we're going to need to update our generate world map function to use the new interface. Been a minute since we've been to main, right? So let's do that and main and generate world map. So we have mapgen index, timer, we clear the history, we set up an RNG. Rather, we get the global one. Now we set up the builder, so it's map builders, random builder, and we pass the new depth and a mutable reference to the RNG. Except I think that's a problem. Yeah. Did I type the wrong thing in here? I did. All right, so that should be a little bit happier. No? Oh my goodness. My bad. That should be a little bit better. Where are we at? Okay. So that's happier. Next up, let's see. We have RNG. There we are. And we have the builder. So it's map builders. Okay, no, that's what I just did. Now build map, and we need the RNG for that. Then we're going to drop. Oh, okay. So that's an interesting thing we haven't talked about before. It's very simple what it does, but we'll explain it. I'm sure the text will as well, but it's very, very simple. So then the snapshot history, self.mapgen history, builder.build data, right? That history.clone. Players start, world map resource. So we get that. Now, instead of builder.getMap, we clone the map. And starting position is going to be builder.build data.starting position as mute.unwrap.clone. Lots of goodies there. And we're returning that so that I'm doing it slightly different than the text, but it's okay. And then the spawning works the same, so it looks like we're good. For that, there's still plenty of refactoring. So let's take a breakdown here of what we're doing. Oh, drop is simple. Drop, let's look back at VS Code so we can actually look at it. It's one of the simplest functions you can make. It's pretty great. It's pretty good stuff. Drop is just a way to satisfy the borrow checker, kind of. Well, that's one of the ways you can use it. And that's what we're really kind of doing here. So we don't have multiple borrows of it. As we're like doing things with the resources and all that, I guess. Pretty sure that's why we're doing it. So drop is a very simple function that we can see right here. Is literally defined as a function that takes in whatever the type is and does nothing with it. Notice that it's not a reference. It actually takes in the thing. So what that does is that moves it out of scope. So it might show an example of using scope as well. No, but another thing we could have done is we could have opened up a scope here and did some stuff. That's not what I wanted. Did some stuff. And then after the end of this, right, everything that we did in here could be dropped. So we've seen that before to satisfy the borrow checker. We're doing it here with mem drop instead. And I don't see anything getting mad if we don't drop it from this scope, so I'm not sure why. So we'll look into that when we'll see the explanation here in the text. So we reset the mapgen index, mapgen timer, and mapgen history, so the progress viewer will run from the beginning. Then we obtain the RNG from the ECS world. We'll create a new random builder with the new interface, passing along the random number generator. We tell it to build the new maps from the chain, also utilizing the RNG. We call std_mem_drop on the RNG. This stops the borrow on it, so we're no longer borrowing self either. This prevents the borrow checker errors on the next phases of code. We clone the map builder history into our own copy of the world's history. We copy it so we aren't destroying the builder yet. We set the player's start to a clone of the builder's determined starting position. Note that we're calling unwrap, so the option for a starting position must have a value at this point, or we'll crash. It's deliberate. We'd rather crash knowing that we forgot to set a starting point than have the program run in an unknown/confusing state. We call spawn entities to populate the map. So I keep calling out the whole crashing thing with unwraps and stuff. And there's a point there of what they said, that they want to know when it happens. And I agree, but I think that's what logs and debugs are for. Like debug log statements or something. The other thing is, the argument could be made that we're developing, and so we don't mind crashing. But the problem I have with it is it's a pain to go remove all the unwraps and everything later on down the line. I think it's better to build in proper error handling from the start, so that when you release a game, you don't have unwraps everywhere that potentially crash your game. And you can put a debug mode in the game that you run when you're developing that allows it to tell you, hey, something went wrong or this or that happened. Maybe even have debug panics or something in those cases where you get into those weird states, but have default states built in that only run for safety. I kind of prefer that approach, but you know, there are other arguments to be made. When you're generating maps like this, you could, in a lot of cases, say, you know, we're trying to build a random map, but we ran into a weird issue. Just default to something and you still get a map and the player's not going to know, right? So that's kind of the idea that I'm going for when I say that. So after we do all that, though, after we set the player start and everything, we're going to spawn entities to populate the map. Simple. Modifying simple map builder. So we can modify it, make a simple map builder, making it worthy of the name quite a bit. So here's the new code. That's a big old beefy block there, but it's not that bad, I guess, but it's a lot of stuff happening, right? So let's take a look. Simple map. And in here we have a lot going on. Let me just pull in the uses and stuff to get us started. So, because I didn't feel like going through one at a time. So we have horizontal tunnel, room, apply room to map, apply vertical tunnel. We have builder map, initial map builder, and rect. And we have the random number generator being pulled in. Now our struct simple map builder no longer has any of that. It's just an empty struct that we're allowed to impl the trait for. So now it's going to be impl initial map builder or simple map builder. We're going to have build map. We're going to take a random number generator, the build data. It's a builder map, right? And I think that's it. Yeah. Okay. So we're going to call rooms and corridors. And is that going to make rooms and corridors mad? Yeah. We're going to have to refactor it. Yeah, we'll get to that in a minute. I'm just double checking. Oh, no. Okay, I see how we're doing it. Yeah. There we go. Okay. Well, yeah, it is self. It's no longer being... I got it. Okay. So build map, that's pretty simple as stated, as it should be. Now it's going to be impl simple map builder, impl simple. And we don't need like any of the rest of this. We have an impl here. With okay, no. We have an impl there with rooms and corridors, so we'll use that. That's what I was looking for. So now for the impl simple map builder, we have pub new, and we're gonna box up simple map builder. And so we're going to need to return this as a box. And what did I do wrong? We have an extra something somewhere. Oh, duh. It's the simple map builder I'm looking at. I got the wrong thing. Okay. And now rooms and corridors has a little bit of extra work to make happy. It's going to be... take a builder map and a random number generator. Rooms are 36 and 10. We make a new vec for rooms. We don't need a random number generator. Now we loop through this here. All the self.maps become build data.map. That one's not. So we'll go back to that one in a moment. Build data snapshot, but we're gonna have to change a little bit of that. Okay. So let me go back to the start of this loop now. RNG range from min to max. Yep, the dice rolls are good. New room. Let mute OK equal true. For other room in rooms.iter, because we made a rooms vector already. If new room intersects the other room, okay. If okay, apply room. I think this may be one, by the way, where I did an all before. You can do it iter and you can do it all. And it's kind of, to me, it's nicer than doing this, like, let's make a variable and then check against the variable. We could do that iterator all logic here to make sure no rooms intersect, and then just that would be our conditional, which would open up to this. But we're not going to do that right now. It's a long chapter, and I've got things I need to do. So we're going to try not to get too distracted. So then here, apply room to map. That looks fine. Build data. If not, rooms is empty. New X, new room center. And then this is going to be... So this is a bit different. Where the hell's I come from? Yeah, there's no I. There's an I in the tutorial, but there is no I to find. I'm going to stick with rooms.len. I think it's a typo. Rooms.len is fine. It's the previous room, so it's going to be the last thing in the vector. So I think we're fine there. There's a typo though in the text. So RNG range and everything should be fine. And now we just push the new room in here. Take a snapshot. And then go down here. We add the rooms to our build data. And we don't do any spawning or stairs or anything. Okay. So, similar to what we were already doing. Why rooms and corridors? Did I miss the There we go. My bad. I got sidetracked by the type. I remember when I typed it. Okay. So we implement initial map builder for the simple map builder, which just needs build map. And in this case, building the map only calls this rooms and corridors function. So then for simple map builder, we have a new, which is just boxing up an empty struct basically, which is just making it's data to carry around our logic and stuff, right? And then rooms and corridors, we figure out how many, like what the max rooms are, and we iterate through, we try to make rooms. This is old logic, so I'm just kind of skimming through. We iterate through, we try to make rooms. If it doesn't intersect, we can apply it to the map. We take a snapshot. If the rooms is not empty, we apply tunnels, and that's basically it. Not much has changed. We've removed logic though. So I guess a lot has changed, but we've removed logic, but the core functionality of what we're building is still there. We add those rooms to our build data because that can be used later. Remember, that's our map state. So it's basically the same as the old simple map builder, but there's a number of changes. We're only applying the initial map builder trait. Map builder is no more. We're also not setting a starting position or spawning entities. Those are now the purview of other builders in the chain. We've basically distilled it down to just the room building algorithm. We've set build data.rooms to some rooms, not all algorithm support rooms, so our trait leaves the option to set to none until we fill it. Since a simple map builder is all about rooms, we fill it in. So now we're going to do room-based spawning. We're going to need this room-based spawner in our map builders directory, and we're going to have just the room populating system from the old simple map builder. So I may cheat a little bit on some of this, because it's, you know, a little bit redundant, but we need it. We'll see. New file. Room-based spawners. We have the metamap builder, metamap builder, builder map spawner, of the RLTK random number generator, and the room-based spawner. So now we're going to impl meta map builder for, well, there's not much we can impl for, room-based spawner. And there we go. Simple build map, self.build. We're basically, that's a way to allow the trait to define that function, and then it's a simple way to kind of pass that off to other logic, rather than doing it within the trait itself. So we pass that actual logic, we defer to the impl block of the struct. I don't know if there is a good reason for doing that off the top of my head. You could feasibly put the same code in here, but this keeps the trait implementation very simple, and the map itself, the room spawner, or whatever, is the one responsible for actually doing the building. So what are we going to do? We'll make a room-based spawner and return it in our new function. Very simple. Box it up. And we'll build. If we have rooms, we basically extract them out with the if-let. And we iterate over it. And for each room, besides the first one, we skip one. What are we passing in? Spawn list, of course. Probably not going to be happy. That's the end of that. Oh no, spawn room was defined. It didn't. Oh, I know why we're not getting the autocomplete. We're not using it yet, so we need it in here. I was like, why aren't we getting that? Yeah, I thought we had spawn room, but then it didn't autocomplete and it threw me off. Okay, so we've got our mod working. Very simple. Again, we impl map builder for room-based spawner, which is just an empty struct, just to carry around the logic and stuff, basically. We box one up for our build. We loop through the rooms if they exist. If they don't exist, we panic. If they do exist, we loop through everything but the first room, and we spawn. That's it. Very easy. So let's go back over to the text. In this submodule, we're implementing MetaMap Builder. This requires that you already have a map in build. We've copied the old room-based spawning code from the simple map builder and modified it to operate on the builder's rooms structure. To that end, we if let to obtain the inner value of the option. If there isn't one, then we panic. And the program quits, stating that room-based spawning is only going to work if you have rooms. I read that in a strange way, that it quit stating the inflection was off. And the program quits, stating that room-based spawning is only going to work if you have rooms. We've reduced the functionality to just one task. If there are rooms, we spawn monsters in them. So now room-based starting position is very similar to room-based spawning, but places the player in the first room, just like it used to in Simple Map Builder. I am going to cheat and copy this because it's basically going to be the same kind of code, but we're going to need a new file and stuff. And we'll read over it, but it's going to be very simple. All right, we'll pull that mod in. We'll take a look in here at room-based starting position. We have an empty struct. We implement a map builder and our build code. Just going to ignore the new from here on. Our build code is simply same thing. We loop through rooms if they exist, otherwise we panic. And we get the first room. Actually, yeah, we don't loop through, my bad. We just get the starting room if they exist. And we grab the center of that room and set that as our starting position in build data. Not much to it. So room-based stairs are going to be the same kind of thing, so we're going to just skip through that. And there we have it. Room-based stairs. Same thing. If there are rooms, then we get the last room. We get the center of the last room and make that the stairs position. And we convert that to an index. We set the tile to downstairs type, and we take a snapshot, and we're done. No need to spend any more time on that. It's trivial at this point. So putting it together to make a simple map with a new framework. So let's take another look at random builder. We'll just look at it here. Let mute builder. So we have a new builder chain with the new depth being passed in. We have the start with a simple map builder. We build with, then we add a with on it, a room-based spawner. Then we say with a room-based starting position and with a room-based stairs. Now that we've made all the maps, it should make sense. Or we made all the steps, it should make sense. We start with the map generated with a simple map generator. We modify the map with the meta builder, room-based spawner, to spawn entities in rooms. And we again modify the map with the meta builder, room-based starting position, to start in the first room. And once again, we modify it with the meta builder, room-based stairs, to place a down staircase in the last room. If we cargo run, we'll see lots of warnings about unused code, but the game should play with just a simple map from our first section. You may be wondering why we've taken so much effort to keep things the same. Hopefully it'll become more clear as we clean up more builders. Yeah, I would hope it's already clear that that is a nicer syntax to be using. But why are we mad here? Simple map builder new says it takes an argument. It does not anymore, so we can fix that. And we need to bring in the spawner stuff, so... I'm just being really lazy. It would have been faster to import, though. I could have clicked on it and had to do it for me. Builder chain... Are you mad in... Oh, yeah, we're not... We just removed that. Duh. Oh, no, my bad. We just return builder. No? Am I missing something? Oh, I missed a... I think I might have just deleted it by accident. There we go. I missed a closing parenthesis there. All right. Now I think we're good to cargo run. We should see a very simple map. No pun intended there, actually, but it is simple map builder. And there, it looks like things are working for us. So, some goofy, lots of things in line. Interesting. Very simple. But very nice syntax that we do have here. Much better than what we used to have. I don't know if we're going to do chaining, where we make the builder stuff return references to itself, and then we keep doing dot with, dot with, dot with. I mean, we're doing that here, but we're not returning anything from them, so we have to make them all separate lines. It doesn't matter, but that's another way we could do the builder pattern. It is what it is, though. Doesn't matter that much. All right. So we're going to clean up the BSP dungeon builder. So we can seriously clean up... yeah, we could seriously clean it up. Here's a new version. Let's get started with this, and then we'll look over the main impl and stuff. Let's get started with the trait and everything. Just get us somewhere, right? So BSP dungeon, all the way up to the impl. So there we are. Draw corridor is not showing up. Oh, this is beefy. So draw corridor should be coming in from here, I think. Was I using it before? It's probably in super and common. Draw corridor. Where is that coming from? Yeah, no draw corridor in map builders, but do we not have one? I'm gonna need to look into that as we go forward, I guess. Is that something I removed? It's in common. I'm looking at the text. It's right here. Not the text, the source code. And I'm gonna be a little lazy here. Let's just walk through it real quick. X and Y, or X1 and Y1. I don't like that personally, but it's okay, I guess. Well, X is not X2 or Y is not Y2, then yeah, we're just like incrementing and stuff. Okay. So if X is less than X2, we move X over. Else if X is greater than X2, we move it left. So we're doing X's first for corridor. And then for Y's, we do the same thing. If it's less or greater, we move it in the direction closer to Y2. And then we convert each tile to floor as we do that. So we're just basically dragging a corridor through there. Is that used in here? All right, we'll see where that's used. Not sure why I didn't have that. So draw corridor now shows up. What's going on, Rose? How you doing? Good to see you here. Alrighty, where are we at? We're on build map. That's all good. The BSP dungeon builder. We're just gonna box one of those up now, so it's a lot simpler. I am doing okay. We got a big old beefy session here. Missing struct fields. Oh, it actually does take rects though. We got a big old beefy session here today. And I am hoping I can get it done in time. It's supposed to storm later apparently. And I need to go get groceries and stuff after this. But this is a beefy session here. Not even halfway done. Only like a quarter of the way done. So we have our new function here, which does just boxes up our new BSP dungeon builder. Our build function is going to be maybe a little more interesting now. Let's see. I got to compare to the existing just to make sure. So the first thing we're going to do in here is make rooms. I will show you what's up after I'm done with this map type, but we are making basically doing a roguelike tutorial in Rust. I'm a computer scientist, software engineer, and I'm interested in game programming and stuff, so my favorite language is Rust, so we're using Rust here to build a roguelike, and it's pretty fun, it's pretty cool stuff. We're working on refactoring all of the map design stuff right now to make it better, to make it easier to chain a bunch of different map generation algorithms and stuff together. So there's a lot of just kind of boilerplate type work of getting everything to work with our new desired interface based on the old way we were doing it, which was very cumbersome. So first we're going to make new rooms vec. We're going to clear out self.rect. We're going to push in the new rect. That's fine. We're going to get the first room and we're going to add subrects. So we're just subdividing that room. We're doing binary space partitioning here. And rooms, that's probably all fine. Where things get interesting is sort by, so we can delete the start because we don't actually apply start from the from this anymore. We apply it with our meta map builder. So now we sort the rooms, so that hasn't changed. Corridors should all stay the same. Oh, we have draw corridor in here, don't we? Yeah, we moved it out of here. So now if I do that, it's going to get mad. It should have gotten mad. We're going to remove this as well. This Impel map builder. We're going to remove that. We're going to have to deal with a couple of these in a moment. Let me get back to the draw corridor. Refactoring is... Oh, I need to change from self.rooms to just rooms. Refactoring is a necessary but sometimes not the most fun thing you can do in programming. But the results of it are great. You have some code that's not necessarily the best designed, or it's something that you design as you're going, and later on it's like, wow, it would be better if I do it this way, or I know something that I didn't know last time I was working on this, so I can make it better now. So it is a very necessary thing at times, but again, it's not the most fun thing. It's very cumbersome. And what did I... Oh, I didn't box this up, yeah. I missed a couple things up here. It's kind of a lot going back and forth with a shared text as well. But I wouldn't say this is the most complicated part. It's that we've been building these maps out for weeks, and it's just a matter of restructuring everything now. So it can be very cumbersome. But if you're noticing, all I'm doing here is just usually changing very little as I'm going through. I just add a little bit of text there. We're keeping the same general lines of code and the same general structure of everything here. So we actually don't want the stairs anymore. So after build data snapshot, we can remove all the stairs and stuff. And we will add our rooms. We'll put those into some rooms. Or no, we'll put some rooms into our build data.rooms. And add subrects and all that good stuff is pretty much going to be the same. So where do we get mad next? Is possible gets a little bit mad. So we are going to have to change this a little bit. That's going to break something else. So we're going to add the map to this. And instead of self.map.width, it should just be map.width and map.height and map.xyindex and tiles. And I think everything there is good. So we'll come up here to where we're using is self.isPossible. And it now takes the candidate as well as reference to builddata.map. Only thing you're building is houses in The Sims 4. Yeah, I love The Sims. It's been a while since I've played, but I love The Sims. Yeah, that's what I'm doing. Add a little bit here, delete a little bit there. That's what I'm doing right now for sure. Cannot borrow RNG as mutable. So did I do a bad pass again? I think, is this not one of those where I could just get away with that? Yeah. That should be fine. Yeah. Okay, I see I missed those. All right. We're done with the basic BSP dungeon refactor here, it looks like. I don't think I want to walk through the whole thing. We did the same ideas before, where we removed the extraneous things. So now this is simply performing the binary space partition algorithm on the map. Well, it's like generating us the new map as well, right? New rooms, and we start pushing rectangles in there. We start doing the subdivisions, and it's a fun algorithm. It's really cool, but I mean, we have that tutorial from a couple months ago or something where we did this for the first time. So I'm going to let that speak for itself rather than go through every line again here because it's a lot. But basically, same idea. We removed the extraneous stuff. It's no longer making stairs. It's no longer making spawning enemies or anything. It's just generating the map. So back into the mod.rs, we can, not mod, yeah, this mod, our random builder, we can actually swap that out with, instead of simple map builder, we could swap it out with a BSP dungeon builder. And I missed one thing on the new function here. We no longer need the new depth. So now we can use the binary space partitioning dungeon builder, and nothing else really changed. We start with a builder. We make a builder. We start with binary space partition dungeon. We give it a room-based spawner, room-based starting position, and room-based stairs, and that's it. Take a quick look at the text, and then we will give it a run. So it says here, just like simple map builder, we've stripped out all the non-room building code for a much cleaner piece of code. We're referencing the build data struct from the builder, rather than making our own copies of everything, and the meat of the code is largely the same. Now you can modify random builder to make this map type. And we've just done that. So if we cargo run, we'll get a dungeon based on the BSP dungeon builder. So as it says, see how you're reusing the spawner, starting position, and stairs code. It's definitely an improvement over the older versions. If you change one, it can now help on multiple builders. Yeah, so the argument there is what we had in the past was literally every single thing was kind of in charge of its own starting position and all that. And then if you want to change how it works, you might have to change it in many places. So let's cargo run our code here. And now you can see kind of how this works, Rose. We're going to see the map build. It's going to show like little steps of the map building right here. You're going to see it build a bunch of rooms and then draw corridors and stuff between those rooms. Link them up. And now we can actually hop in here. And we have a simple little corridor-based, room-based map that was generated with the binary space partition algorithm. And we can run around and we can fight things and do fun stuff. Simple roguelike, kind of setup going on here. So we have another map here. I'm not going to spend a bunch of time on there because we still have a lot of work to do on going to the next things. So we could do the same for BSP interior, which is going to be, once again, very similar. I'm going to cheat a little bit and bring in some of this to speed things up. And at some point I may start cheating a bit more because it's also very similar. Expected 2 arguments, or expected 0 found 2. Why? Oh, because self.build. So we'll bring this in here. I really like this BSP interior one. It's one of my favorite ones. I like the way it looks. It's really cool. So we're not going to do start and starting position anymore. So we'll do the corridors, however. And it's not going to be self.draw corridor anymore. It's going to be and mute build data.map. Boom. And we're going to have to remove this other implementation wherever it's at. Yeah, this impl map builder for BSP interior, remove that. And that's going to allow a lot of other things to break, which is actually what I want. So now all the maps can be replaced. Actually, we don't need draw corridor anymore because we're using a different draw corridor. We've extracted that as well. Now there's a lot of things. It's yelling at me. It's very angry. So let's go to the top of build because we're going to need rooms. So we're going to have a mutable vector called rooms. And it's a vector of rectangles. And we're going to clear out self.rect. All right, that push. First room is just going to be... Oh, wait, sorry, we had to... there we go. There we go. Okay. We have this one here that's called rooms copy now. So rooms copy. I'm going to refactor that all the way down, and I hope that's not going to be too bad. For R in rooms copy, let room equal... It's a, so we're just dereferencing it. And then we have here rooms.push. All the maps we change with build data.map instead of self.map. And we'll take that snapshot. So now we want corridors. Self.rooms gets replaced with just rooms. And we will take a snapshot at the end of the corridor thing. And then we'll remove all the spawning and the stair creation. And we'll hand these rooms over to the build data. And there's one thing that's mad right now. We already have a mutable reference to RNG, so we just need to pass it in as RNG. And that's it for BSP interior. So all I have to do is change this to BSP interior builder. And literally I've changed nothing else in this code here. And if we run it, we should get a really cool BSP interior map now. This is such a simple algorithm, but I really, really like the way this one looks. And let's run that again. Let's see another one. Oh, we're getting a weird generation there. Of course, it's going to be different every time. It's random. So we got a lot of big rooms and a lot of tiny rooms in the corner. It's going to be different every time, right? It's a lot of fun. There's a lot of learning I'm getting from this. But it does look really cool. I can't take full credit for it because I am following along with something else, but I'm learning a lot of this because I'm going to be applying this to the game that I make. I'm going to be using these algorithms and techniques that I'm learning here to the game that I'm going to be making. I don't want to take full credit, of course. I mean, I'm not trying to hide that I am following along with a text as well. So yeah, we've just tested BSP. Cellular Automata is going to be a really cool one. That's another... Okay, like a lot of these are one of my favorites. I am making a game right now. I'm working on the design document, still trying to narrow things down. I'm really debating a lot of things on how I want to approach, but I'm trying to narrow down my ideas. There are some problems. I'll make this quick as a quick aside. One of the problems that people that want to make a game often run into is they have too many ideas and they say, well, I'm not ready to start. I need to do this before I start. I need to do that before I start. And they never actually get started making the game. So sometimes it's better to just start doing something and get some progress than it is to sit there and say, I'm not ready. I'm not ready. I'm really trying to push myself to that point where I do get started. And so I'm at the point right now where I'm just debating on what tools I want to use to do it. And I'm really close to actually getting started while I'm also still working on the design document. Because the other issue is I've got a million different ideas of things I want to do. I can't realistically implement all of those. So I want to kind of narrow down and figure out what my real focus of the game is going to be. But before I even do that, I should just get started making something, right? And so this is another way. on the side, while I'm working on my own stuff, doing this here gives me techniques and you know, I get to learn things that are going to be helpful for my own project, you know. So cellular automata is really cool. So the text says you should understand the basic idea here now. We're breaking up builders into small chunks and implementing the appropriate traits for the map type. Looking at cellular automata maps, you'll see that we do things a little differently. We make a map as usual. This obviously belongs in cellular automata builder. We search for a starting point close to the middle. This looks like it should be a separate step. We search the map for unreachable areas and call them. This also looks like a separate step. And we place the exit from the starting position. That's also a different algorithm step. The good news is the last 3 of those are used in lots of other builders. So implementing them will let us reuse the code and not keep repeating ourselves. The bad news is that if we run our cellular automata builder with the existing room-based setups, it will crash. We don't have rooms. So we're going to start by constructing the basic map builder. Like the others, it's mostly just rearranging code to fit the new trait scheme. Here's the new cellular automata.rs file. So let's work with that. Traits here, I do love traits a lot, and they're similar to interfaces in Java. It's not necessarily 100% unique to Rust, but just feels great the way they're used here. This does really show how you can use them very effectively. All right, so I need to go, I'm gonna get rid of the map builder thing, get rid of all that, go to here, and there we go. A lot of just kind of free copy there. But it's the same thing we've been doing. We implement the initial map builder, a very simple function. It just basically calls a build. We have our cellular automata builder struct, which is just an empty struct, and we box it up in our new, and now we get to our build function. So this one's really angry at us. So let's see how we can make it happier. Well, first I see, without even looking at the text, I see that we have a lot of blank.map, not build map, build data. In fact, a better way to do this would be Control H self.map with build data.map and replace all of them. That should clean up a lot of the anger that was in here. It was really yelling at me. And self.take snapshot with build data.take snapshot. 4 of those are now handled. All right, that was easy. Let's see if there's anything I need to do at the top. We can remove this random number generator. And that does remind me to make sure I removed the ones from over here. I did, okay. Cellular automata, back to this. We do that initial thing, which is where we randomly seed our map with just random floors and tiles, and we take our snapshot. Now we iteratively apply cellular automata rules. I don't think anything is really changing there, but this is where things get a little bit different. A lot different, in fact. We no longer need the starting position, the start index, the exit tile, or the noise areas, or the spawning code. So we can just remove all of that, and I think, yeah, we're good. That's it. Now, the map's not really going to do much yet. We can't really run it yet because we need starting points and everything. So slink back over to the text here, and we need non-room starting points. We're going to be doing the Voronoi noise spawning. Well, there's a loud sound outside over here. What is going on outside? Non-room starting points. It's entirely possible we don't actually want to start in the middle of the map. Doing so presents lots of opportunities and helps ensure connectivity, but maybe you'd rather the player trudge through lots of map with less opportunity to pick the wrong direction. Maybe your story makes more sense if the player arrives at one end of the map and leaves via another. Let's implement a starting position system that takes a preferred starting position and picks the closest valid tile. So we're going to make area starting position.rs, and I'm going to bring in the initial impl, like just basic stuff here, and we'll go from there. Just the boilerplate code that we don't want to type over and over. So in our map builders, we're going to say area starting position.rs. Do look forward to seeing cellular automata working again. It is a really cool algorithm. All right, so we have X start, Y start. Those are simple enough. They're enums that just say, are we at the left, center, right, top, center, bottom? We have an actual area starting position with that X and Y start enum. And we have the meta map builder that we've implemented for area starting position. We also have the area starting position. We're just boxing that up with an X and a Y. So we're actually packing it in here. So we'll see how that gets used. I think I already know. We're going to set the starting position, and then later on we're going to apply it, I imagine. Or you know, we'll see. So let's go to fn build. And it takes a mutable reference to self. Unused random number generator. And a mutable reference to builder map. We're going to make seed X and Y, a couple variables here, and we're going to match on self.x. We have three options, so I know why. I need to add area starting position up here. I was like, why am I not getting my autocomplete? I want it. All right, in our match. All right, so if it's left, we're gonna say seed X equal 1. I'm gonna change this code a little bit once we've written this because I don't like this format. Seed X equal build data dot map dot width minus 1. So simple math on this. If it's left, we just set it to the far left of the map. If it's right, we set it to the far right of the map. If it's center, we just divide the width by 2. That's our center. Clippy will not be a big fan of this. And I agree with Clippy. So if our Y value, we're just going to say 1. I'm just going to shortcut this a little bit. Build data dot map dot height over 2. Build data dot map dot height minus 2 gets us to the bottom of the map. And now instead of doing it that way, I'm going to put a semicolon at the end of that and say seed Y equals that, and seed X equals that. Remove the seed X equal from all of these. A little bit cleaner to read, in my opinion. Alrighty. And next, once we have our seed X and Y, which just says where do we want to start the character, available floors is going to be a vector of usize and f32. So f32, just from looking at what I haven't even looked ahead yet, that's probably going to be distance. We've done algorithms like this before. What this is probably going to be is the index of where the tile is at and how far away the tile is, because we're trying to determine the closest valid tile to the desired starting position. So let's just keep that in mind. For index tile type in build data, data dot map dot tiles dot iter dot enumerate. If tile type is floor, then we push that into the available floors, which is going to be Let's see. It's going to be the index, which is our enumerated U size from above. And it's going to be RLTK distance algorithm, distance alg, Pythagoras squared, got distance 2D. And now we're going to want to spread this bad boy out onto a couple lines here. So the starting is going to be a point, RLTK point. And I got to scroll over to make sure that's right. Yep, divide by width. RLTK point new seed X seed Y. So that's a big old beefy boy. We'll talk about it in a moment. I will break this down because it's new code. But it's things that we've kind of seen before and worked with. So there's the push, boom, boom. Now, if available floors is empty, we panic. No valid floors to start on. For you, pretty much every code is new. Code, I had my first professor in university said that our job as computer scientists is to make it look difficult, to keep our jobs safe. Code is intimidating at first, but it's actually not as bad as it looks. It depends on what you're doing too. Every language is a little different. So, you know, you learn how to do things in one way, and it may not quite be the same in another language, but the same general ideas and constructs apply across all languages for the most part. So it's a lot easier once you know one language to learn more and to apply that knowledge. So it's kind of that initial learning curve of your first language. And then you learn tricks. Like this little trick that I'm doing here is something that you learn over time. So we're going to get this start X and Y value by doing this divide, this mod and divide algorithm, if you will. And it's because of the way we're working with our data. So these are kind of things that you figure out maybe the first time you draw a picture and you kind of work with it a little bit, and you learn how these different approaches, these different little tricks and algorithms and stuff work. And then that's like a tool that you can use in future programs. But really, that's all programming is. It's like a tool, right? It's a tool to do. Yeah, we're just gonna do this. Just gonna get rid of that altogether. Okay. It's like a tool to do things that you know you don't want to do yourself. For the most part, that's how you can look at programming. So it's kind of a good thing to have under your belt if you spend a lot of time on computers. To be able to do basic programming, I think, is a nice tool. I use it for so many things, like repetitive tasks or whatever. It's like, I'm going to write code to do this for me. All right, so let's break down this code here. It is not the worst, and it's stuff that we've done before in these tutorials, so it's going to be very similar. Some of this is similar to what we've done in the last couple of sections with the prefabs, with the pre-generated maps. So we get a seed X and a seed Y value, which is really just what was kind of passed in, what was already set for us, which is an X start and an XY. So it's either left, center, right, top, center, bottom. And then we want to get all the available floors. So if the tile type is a floor, We loop through every single floor basically. If the tile type is a floor, then we want to get the distance. So yeah, so we push that index of the floor wherever it's at on the map. We push that index along with how far away it is from the starting point, which is like wherever we're currently at, to the desired location, seed X and seed Y. If there are no available floors, if it's empty, then we panic and we get out of there. We failed. If they're otherwise, we sort them by distance. So that's what we're doing here with the A.1 partial compare to B.1. And what is the dot one? Again, we pushed in that tuple. Where did it go? Available floors. Here it is. It's a vector of U sizes and F32s. So the F32 is our distance. So the A.1 and the B.1 is our distance. So we're sorting by distance. And then whatever the first one is, available floors 0, is our closest tile to the desired starting position. So we rip out the X and Y values from it, and that is our starting position now. You said lazy. Indeed, that's actually a legitimate thing that a lot of people say, that if you're hiring a software engineer, you want a lazy one, because they're going to find the easiest, like best way to do the job with the least amount of effort. That's a legitimate thing that you will hear people talk about. All right, so the text, back to it now, because that was a lot of typing. We've covered the boilerplate enough to not need to go over it again, so let's step through the build function. We're taking in a couple of enum types, preferred position on the X and Y axes. So we set seed X and seed Y to a point closest to the specified locations. We iterate through the whole map, adding floor tiles to available floors and calculating the distance to the preferred starting point. We sort the available tile list, so the lower distances are first. And we pick the first one on the list. Note that we also panic if there are no floors at all. The great part here is that this will work for any map type. It searches for floors to stand on and tries to find the closest starting point. So then we're going to do calling unreachable areas. We've previously had good luck with calling areas that can't be reached from the starting point. So we're going to formalize it into its own meta builder. And it's not a lot of typing, but we'll get back the initial boilerplate, and I'll just do that bit of typing there. So in one of the first coding streams I did, I built like a macro runner. You know, like if you set a macro up, like to press keys and click, you know, move the mouse and click on specific spots and everything. I built one of those on like one of my first coding streams. And I mean, it works. I've used it for like genuine repetitive tasks. Like I need to, you know, like some website had a bunch of saved stuff and it's like, I want to delete this, but there's no good way to delete it on the website. So let's build a little macro with my own program that says, click here, click there, you know, wait a second, click there. And then like you've deleted it. So now like refresh the page or whatever, like things like that. And then I looked at how many things do I have that I need to delete. I have like, say there's 1,000 and it takes, you know, so I need to run my deal 1,000 times. So I tell it to run 1,000 times. And then I just said, okay, if it takes, you know, 7 seconds to run, then that's how long. And then I just like walked away and I came back later and was like, all right, cool, it's done. It did all the work for me. I just like, I went and like ate and stuff. And when I came back, it worked, you know. That's the laziness in action right there. It's like, I want to do this, but I don't want to do it myself. I'll just make my own program do it for me. All right. So we're going to do call unreachable.rs. And we're going to add that here. We're going to get our boilerplate here. Alrighty. So we have a empty struct. We're implementing meta map builder. And the box just returns one of those. Nothing special at all about it. Okay. So what are we going to do? Let's starting position equal build data dot starting position as ref. .unwrap, .clone, lots of things going on there. We're going to get an XY index out of the build data map from our starting position. I misspelled unwrap. There we are. Now with our index, we're going to do build data .map .populate blocked. We haven't used that in a while. I kind of forgot that one was there. Okay, so map starts. We're going to make a vector, and all of them are going to be populated with the start index. Okay, I see what's happening. Because we're using the Dijkstra map. What else do we need? Oh, that is way too much. That is way too much for one line of the tutorial. Let me try to split this out a little bit. All right, I think that's good. Yeah, it was way too much to put on one line. It's unreadable. No, he's formatted and it all looks great. So the Dijkstra map, we're going to populate with the width and height. Simple enough. Map starts is telling us where on the map that we're located, but it does have to be a vector. And I remember why. We'll talk about it in a minute. We have build data.map, which is our actual map. And we have 1000 is our max depth. If anything goes that far, then it will fail. Now remember, map takes this base map, which is an RLTK type that we implemented for our map. So the map starts has to be a vector because this actually runs for all positions that you give it. So you can actually run this for more than one position. We're only running it for one. So you may hear it described as something like all pairs shortest paths in computer science. You could do that for every single position on the map. You may hear something like that. That's kind of what you'd be able to do if you ran it for every index. There's a couple algorithms that can be used for that. You can use Dijkstra's algorithm. You can use Floyd-Warshall algorithm. And there's another one I'm forgetting right now, but there's a few different algorithms you learn that can do that. Okay, so we have the Dijkstra map being created for I tile in build data.map.tiles.iter mute.enumerate. So we're going to be changing the tiles, iterate through them and change them as we go. If tile is floor, let distance to start equal Dijkstra map.map, and then we'll actually get that I, right? That value, value from the map. So if we can't get to the tile, we'll make it a wall, and we do that by saying if distance to start is std f32 max. There we go. So the algorithm, this is common in algorithms like this, it returns the largest possible value if it's impossible to reach. So that's why we check for F32 max. And we can do an equality there. Normally you don't on floats. You do min, max. You wouldn't do an equality for the most part unless you actually know they're going to be equal. Floats, of course, have problems. They're not perfectly accurate. So a floating point number, if you put 1.0, it may not actually be 1.0. It may be 0.99999999999, and you just think it's 1.0 because that's what you typed. So floating points are not perfectly accurate. Because of that, equality is discouraged. But we know that we're actually using the explicit value F32 max. So you could do like you could say let test equal 1.0, let test 2 equal 1.0, and you could compare those because the numbers are going to be the same. 1.0 is always the same number, even if 1.0 is actually 0.999 whatever under the hood, right? Because then they'll both be that same 0.99999 number. So just making that note, unless you know you're explicitly using an exact comparison like this, try to avoid that with floats because they're not precise. So let's go back to the text now. You'll notice this is almost exactly the same as remove unreachable areas, returning most distant from common, but without returning an extra map. That's the intent. We remove areas the players can't get to and only do that. Next up is going to be Voronoi-based spawning. We're going to need to replicate the functionality of Voronoi-based spawning. So we'll make Voronoi spawning.rs. That's another slightly beefy one. Trying to speed this along too. Not trying to rush. There's a difference between rushing and moving with brevity. Oh, I see why. I put that in the wrong place. There we have it. So Voronoi spawning is now in our map builder stuff. And we have the basic boilerplate we're not going to go over anymore. We're going to make a hash map of noise areas. The map is going to be I32's mapping to a vector of U size. We're going to make noise, which is going to be RLTK, fast noise, seeded. We're going to seed with an RNG.roll dice. It's going to be a 1D 65,536 as U64. That tells me that the seed value that we're using is a 16-bit value because 65,535 is the max value for a U16. That's a lot of sides on that dice, right? A 1D 65,536. That's a pretty big dice. We're going to set the noise type to an RLTK noise type cellular. You know, I guess with a dice like that, you'd never lose your rolls in D&D for the most part. It'd be hard to roll less than a 20. Alrighty, so we got our noise type, our noise frequency, and our cellular distance function is Manhattan. We do some simple loops here for y in 1 to the map, whoops. From 1 to the map height -1 for the edge. For x in 1 to the build data.map.width, -1 for the edge. Let index equal build data.map.xy index. All right, if the tile that we're currently looking at is floor, let cell value f equal noise.get noise x as f32, y as f32 times 10240. And I believe we looked at that magic number thing before. It was just a way to get the data from being really small to something that's usable. And then we convert it to an I32. If the noise area, okay, we're gonna do this the other way. They're doing a hash, they're doing the hash map this way where they check if it's there, do it, and all that. We're gonna do it my way, which is nicer. So noise areas dot, now I gotta remember what the function is though. Dot entry. And let's see. What are we checking at? I lost it. And cell value. So we get entry cell value dot and modify. And we're going to say that dot or insert. We'll break this down in a moment. Oh, right. Here we go. Okay. So use of or insert followed by function call, right? Or insert with. There we go. Okay. Nice hash map access. It almost reads like English. The corresponding text in the tutorial looks like this. Let's compare and contrast. We're doing the same thing. If noise areas contains the key cell value, then get a mutable reference to that key and then push the index into it. If noise areas does not contain the key, then insert cell value key with the vector index. We can look at it this other way now. We could say, get the noise areas entry for cell value and modify it by pushing index into it, into the vector, or insert a new vector. So just a slightly different way to do it. I think it's nicer. It's not as common because I don't know if there's anything like that in like C++ or something, but it's pretty nice to work with. I like it. And we're just gonna go with V on that. We're gonna keep it as that. So go down a couple times. We've built out all of our good stuff there. Yeah. So now we're gonna spawn the entities. We're gonna say spawner spawn region. It's gonna be build data.map RNG area.1. That's not what I wanted. Area.1 build data.map.depth. And is build data? Yeah, build data has a spawn list. So and mute build data.spawn list. Big old beefy function there, but we are good. Same thing we've seen before. When we wrote this the first time, We set up the noise type and the frequency and all that fun stuff. We seed it. We loop through all the tiles in the map. If it's a floor, we get a value of noise for that tile. And then if that value already exists, we push that floor index in. Otherwise, we start a new vector for that cell value that we got from here, right? The noise value. And then we simply iterate through all the different noise areas and spawn. So let's scooch back over here. As they say, it's almost exactly the same as the code from common.rs. We were calling in various builders, just modified to work within the builder chaining builder map framework. Now we're going to do spawning a distant exit. We're almost ready to actually run the cellular automata test again, but there's a lot of work to do to get there. But this is the same kind of stuff. I'm going to just grab this one because it's almost the same thing we just did. We're going to break down line by line and just talk about it real quick. But I always say, don't be lazy when you're writing new code. This is not new code. The first time you write code, you should really make sure you understand it. You should write it yourself. This is refactoring. It's more okay to do that during refactoring, because we've already seen all this before. Not a big deal, right? Yeah, don't make a bad habit out of doing that. Like you're following a tutorial and you say, I'm going to copy everything, just copy paste, because you're not learning. You're not doing anything, right? So we implement map builder, simple enough. Distant exit is just an empty struct. Box one of those up. We're all happy there. So our build function now, we get the starting position that we already have, converted to an index, populate blocked on the map. Map starts is we're doing the Dijkstra map again. So this is what we saw just a few minutes ago, right? But now we get the exit. We're setting an exit tile and we default it to 0. We're saying it's 0 distance away. So now what we actually want to do as we go through this, we want to find the furthest tile. That's kind of what we're going for. So if it is further away than our current exit candidate, we set that as our new exit tile, because we want to get the furthest valid tile. But it has to also be one that's not the max F32 value, because that's like infinite. We can't do that, right? So we just find the furthest tile. That is now known as exit tile once we're done with that. So we use that to place a staircase there. That's all there is to it. Again, we've written this code before. The tutorial also says as much. It's the same code we've used previously, just tweaked to match the new interface. So we won't go over in detail. They don't think it's worth going over detail. I don't think it's worth going over in detail. We don't need to do it again. So now we can test cellular automata. We finally got the pieces together, so let's give it a test. And just so I don't have to change the algorithms around, we'll just read what it is. And we'll take a look at it. It's finally time to test it. I'm glad, because it's a cool algorithm. It's fun to watch. Oh, whoops. Just the center parts. Just the meat. As a reminder, cellular automata works by... I didn't pull... let's do it this way. As a reminder, cellular automata works by having some starting state of the map, which in our case randomly sets like half of the map to floors and half to walls. Have some starting state of the map, and then it has a simple set of rules that say if this cell, each tile of the map, each spot on the map, call it a cell, if each cell has some number of neighbors or less, it behaves in one way. If it has some number of neighbors or more, it behaves in another way. So generally speaking, maybe if you want to go with Conway's Game of Life, the standard version that everyone kind of sees, it's like if there are less than 2 neighbors, then it dies off. It would disappear because it's almost like it can't reproduce or something. And if there are, say, 2, 3, or 4 neighbors, it can live on to the next iteration. Or if there's like 7 neighbors or something, if there's more than 4 neighbors, it dies off as if it's overpopulated and it can't sustain itself, right? So we applied some similar rules to our maps, to our cellular automata algorithm, where depending on the neighbors, tiles either become walls or floors. So we will see that in action now. It'll run through a few iterations, and it looks really cool to watch. Here we go. And that was our map. Run another time or two. We can also wander around the map, of course. We got placed in the center. We got some goblins and stuff running around, but we are good. All right, that's another one done. Still a lot more to go. I might get a little bit, and even the tutorial is getting a little bit lazier now. You should have a pretty good picture of what we're doing now, so we'll gloss over the changes to drunkard.rs. So let's skim it here, and then I'm just going to copy this file in for the sake of saving time. I think we've got the point now. We've done both kinds now, the ones that use Voronoi and the ones that use the basic spawning and everything, the room-based stuff. So we've kind of done all of that. So rather than going over this long file, change by change, we're just going to kind of bring it in. It's not the most difficult algorithm. Let's try to verbalize what Drunkard's Walk does again. Drunkard's Walk would pick a random starting position and move a thing around randomly and carve out tiles. It's like a little miner that carves out tiles as it goes through there. And then we have like 3 different modes in which it can run, like a random spawn or from a specific starting point or whatever. And we also had a thing where like the brush size could be changed. So by that I mean like when he digs out 2 tiles instead of just 1. The floor percent, how much of the floor we want to dig out can change. The lifetime of the drunkard changes, and so on. But again, we simply pick a starting position. Let's see, we keep track of how many diggers there are. So while the floor tile count is less than the desired floor tiles, we spawn a drunkard, we have him walk around carving out the map, and we do it over again until enough of the floor is carved out. Simple. I don't really want to dwell on it. And I think it's self-explanatory now, you know, for anyone who's at least a coder following along. I think it's self-explanatory what we're doing with these refactors. I don't think it's necessary to dwell on every single line at this point. It's very, very time-consuming. So we'll take another look at Drunkard's Walk running now with the refactor in place. And it's always a fun one to watch too. So we had symmetry applied there. We did the fearful symmetry version of it. So you could kind of notice that symmetry happening. Yeah, cool stuff though. All right, done with that one. What is next? Probably diffusion limited aggregation, DLA. More of the same, so again, we'll just provide the code. And that's all I'm going to do at this point. DLA had some similarities to the Drunkard's Walk. It was a little bit different. We would either start from the center of the map and go outward, or we would start out and like move towards the center of the map. It had a lot of similarities though to the Drunkard's Walk. It's a pretty cool one to watch. Where is DLA? Making sure we're all good. We will run it. DLA builder. And what do we want to run here? Central attractor. We'll do central attractor. I think insectoid is here as well. We'll take a look at insectoid. It's really cool. We'll start us in the center of the map. Let's take a look at DLA running. One of the nice things here is with this kind of setup, we can even make map generation. Oh, I forgot how slow this one is to run though. Yeah, this one can take a while to run, so I don't think we're going to wait for the whole thing. Let's take a look at insectoid real quick. Because I really like the look of that. But we could almost even move some map generation now out of the code and move it into files. But you would have to ensure that your files actually conform to the right specification. You could make some kind of linter that checks that to be like, hey, you got to do this before you do that. But it'd be really cool to even make map generation something that's data driven by like, you know, a JSON file or something like that. I think it'd be cool to watch. And now you see why they call this insectoid, right? Looks pretty cool. It does kind of look like a crab on this one. Kind of like Space Invader kind of creatures as well a little bit when you do these. I just hate how long this one takes. It should probably be taking fewer snapshots. I think I have my original code taking fewer snapshots. Run it one more time real quick. I just want to see what kind of weird creature we get this time. So the reason we're getting this kind of interesting shape is that we do dual symmetry. So we get this really cool effect coming out of it. Looks like a little bee or something right now. I don't know. It's fun to watch though. Now it's almost more like a moth, I think. All right, next is another fun one, which reminds me of something I saw last night. Butterfly, maybe, yeah. This reminds me of something I saw last night, which was a Dwarf Fortress post on the Reddit forum where they captured a minotaur and they built a maze, a labyrinth for it to live in. And then they're building traps where they can dump enemies into the labyrinth with it, because of course. So here's the code for maze. And the maze is going to be very similar to a lot of the other stuff we've been doing. Not really much is going to change there. The maze was a fun one to implement. This is weird. It's very bittersweet in a way for me, because I've been doing these over the past, I don't know, like almost 2 months now. These map generation stuff. It's been, I think I started them in November. And it's almost bittersweet to be like, oh man, we're basically done with map generation. We're just cleaning everything up at this point. So again, only copying because we've done this refactoring for multiple functions, or for multiple algorithms now, and I don't feel like going through 200 lines of doing it right now. I'm going to be lazy. Oh, whoops. Cancel that. We need to actually use the labyrinth. What do we call it? Maze. Maze builder. New. Let's take a look at our labyrinth. Hopefully they have it generating quickly. Oh yeah, we got a quick maze, good. Next, we're going to do Voronoi maps, which are another one of my favorites. So I'm not even going to click back over to the tutorial text at this point. We're just going to go through them one at a time, basically. Voronoi.rs is the Voronoi maps. And which new functions, which constructors do we have? New, Pythagoras, and Manhattan. Well, I don't have a general preference, so we'll go with new. it's the same as Pythagoras. They just kept the old new function. That's fine either way. So Voronoi cell builder. Now, this is a cool one. You call it Voronoi cell or hive maps. I'm a big fan of the way these look. So let's take a look at this one. I also like watching this one build from the top down. It's really satisfying. Really like the way that one turns out. One more, because it's so fascinating to watch. Now I want to go ahead and while I'm thinking about it, make this comment. Again, I've made this comment many times throughout the tutorial. It's easy to look at something like this and think, well, this is cool, but this is a specific kind of game, right? This is a 2D roguelike game, so it's not going to be useful for a 3D game that I want to make, right? But that's not true. Data is data. All that matters is that you tell the computer how to use the data in the way that you want to use it. So using, 3D is just one extra variable on top of 2D, right? So you could make this map here and then add an extra layer of it, which is like the 3D height mapping or whatever, where you could make, you could use something like a noise algorithm to generate varying ceilings. If you wanted to make like a cavern that's not just uniform height, you could make a very basic like Doom Engine kind of thing where the ceilings are all kind of the same height for the most part. Well, they're not really, but like a Doom Engine hallway or something where it's all just one height through the hallway. You could do something basic like that. That would work. Wouldn't be as exciting, but you could add like that third dimension, right? Data is data. It's all how you use the data that matters. So these algorithms are useful for any type of game that you want to make. Next, the one that I was most excited about probably going into the map generation, wave function collapse. Now this is actually going to be different, and we'll spend some time looking at it because of that. So let's click back over, because wave function collapse is different. So the idea. All right, Rose, thanks for hanging out. I hope you have a good one, and I'll catch you later. Take it easy. So wave function collapse, as a reminder, is an algorithm where you take some kind of starting data, you break it up into little chunks, little tile chunks, almost like a sprite sheet, and then you define rules and constraints on how they can be pieced together. You randomly pick a tile in your map and you randomly assign it one of those chunks. And then that makes limits on what the adjacent tiles can do. So now an adjacent tile can only pick something that's valid to go next to the one you already set. So that lowers the possible domain that could be on that tile. So then you just keep randomly picking tiles that have lower domains, ideally. So one of the ones that's next to one tile that you've already made. And then you randomly pick from within its valid tiles. So I used the example before. If sand can go next to water or grass, then if you place a sand tile, the tiles next to it can only be sand, water, or grass. So instead of like maybe a total of 10 possible tiles, now they can only be three possible tiles, sand, water, or grass. So then if you place a water tile next to that sand, well, maybe tiles next to water can only be sand or water. So they can only have 2 possible values. That's their domain. So that's the general idea of wave function collapse. And because of that, we needed to take in another map to do it, right? So the way it works is it was kind of using that concept of a previous builder, but we're building that into our new chaining functionality, which is the whole point of today's session, right? So the text says wave function collapse is a slightly different one to port because it already had a concept of a previous builder. Well, that's gone now. Chaining is automatic, so there's a bit more to update. Wave function collapse is a meta builder, so it implements that trait rather than the initial map builder. Overall, these changes make it a lot more simple. The changes all take place in wave function collapse mod.rs. So let's get us down here to the start of build. And let's just kind of work our way through this a little bit. See what happens. That's not what I should do. Oh yeah, we're losing a lot of stuff from here though. It's going to be cool. Going to be good. So we just go all the way up to the top here. Boom, all that's gone. Now some things are going to be a little mad, but it's okay. I gotta kind of run through this one. We gotta do this one for real a little bit. Render tile gallery is still good. So we're gonna do, instead of self.take snapshot, it's gonna be that anywhere we see it. And self.map, it's gonna be build data.map. Let's go ahead and get that out of the way. That's gonna get rid of the majority of the anger. Now I can look through this with a little bit more ease. So we have our chunk size, we take a snapshot, we have no more pre-builder stuff. We actually skip all the way down to patterns and constraints. Render tile gallery. And this is going to be build data dot map dot where are we at? Sorry. Wait. What? Oh, okay. Wait. Okay, I see where we're at. So render tile gallery map new with build data dot map dot depth. Sorry, sometimes it gets a little bit confuzzling. Everything else remains the same until we get down here. So after the solver break, if solver possible, break. Get rid of a bunch of this. We're not spawning or anything. We clear our spawn list because wave function was a little bit special. It's shuffling what already existed, right? Render tile gallery. That needs to have a new argument passed in. Constraints, chunk size, and that right there. Iteration gets the RNG. And I think we are good. We test it with the following code, so let's pull this code in here. I am really hungry right now. It's hitting me. We're almost done though. We gotta go through the prefab stuff and we're mostly done. So we're gonna see a Voronoi cell builder, and then we're going, so our chain is like this, while you're watching it generate. Voronoi cell builder into waveform collapse builder. We're gonna start in the center. We're gonna call, we're gonna do Voronoi spawning, which is just our spawn list, and then we're gonna do our distant exit. So we see it piecing together everything from the chopped up Voronoi map that it just built. Not much looks cullable. Yeah, I like that map. That was good. Oh, whoops. Sorry about that. I don't know how my... I have no idea how my key... I was pressing up and down arrow thinking I was in the game. I have no idea how my keys were in OBS. Weird. That's okay. All right, so back here now. So here's a fun one. The prefab builder is both an initial map and a meta map builder with shared code between the two. Fortunately, the traits are identical, so we can implement them both and call into the main build function from each. Rust is smart enough to figure out which one we're calling based on the trait we are storing. So prefab builder can be placed in either an initial or a meta map builder. So we'll get this initial thing here. And then we'll click back down there. Where are the prefabs? Mod? There we are. Now we have the meta map builder, and we have the initial map builder, both being created here, both being implemented. We have our Rex level, our constant, our sectional. That's all pretty much standard. That's the same for this prefab before. So now is where it gets interesting. We have a lot of constructors. And we have... Okay, let's just get the constructors for now. Those are easy enough for me to just do that. We box them all up. We put the correct data in each one. It's not really difficult or special, right? Yeah, so the prefab mode, by the way, is the Rex level and stuff. That's right. That's the enum. I was looking at the wrong thing. The prefab builder struct takes the mode. So yeah, we only need one thing in there, which is nice. Now we take a look at build, which is way at the bottom on mine. And a lot changed. No stairs, none of the start index, none of the starting position. A lot changed for sure, yes. Now we have self.mode. Constant, sectional, room vaults. We're going to have to change everything to take build data. We've been doing that already. So what I mean is instead of self.map, build data.map, self.take snapshot, build data.take snapshot. That's going to help us out a bit. All right. This is going to be a little bit of a messy one to get through, I think. So build is good. Now we need care to map, which I did mine slightly differently in the order, so that's a pain. Care to map takes after the index build data dot, I don't know, build data and mute build or map, builder map. Self.starting position is now and spawn list. So self dot okay, what was the other one? Spawn list. Less anger or more, because we may not be passing it in everywhere yet. What's wrong with this? Oh, it's now optional. I forgot. Yeah. So this takes some. position rather than just a position. So that's good. Care to map is now done. What's next? Load Rex map, which mine's up here. Load Rex map has to take in new stuff. Oh, it actually, hang on. There we go. And self.care to map takes in the build data here. All right, after load Rex map, we have read ASCII to vec. I did mine slightly different. We can go ahead and bring that in though. It's going to break a couple of things, but we can do that just to be in more parity with their code. Load Rex map. Read ASCII to vec. A couple things are going to get mad about it, but it doesn't actually change. Okay, we have load ASCII map. Takes the prefab level and build data with the builder map. Read ASCII to vec now needs to be prefab builder. Read ASCII to vec. Nothing else changed. And self.care to map. You've already done, right? It's builder or build data. Next, care to map is good. Apply sectional? Yeah, apply sectional is next. Read ASCII to vec, we'll update that. This needs build data. Care to map needs build data. All right, apply previous iteration. Oh, we're getting rid of that, aren't we? Oh no, it's still here. We're getting rid of some of it. Oh, right. I remember this one now. Copy that so I don't gotta scroll over in their text. So we have the RNG being unused here. Build data, pretty standard. So self.previous builder, like a lot of this is not going to be valid anymore. We're doing some of the same kind of stuff, but we're doing it differently. So just start over. Let width equal build data dot map dot width, build data dot spawn, list dot retain. So we call that filter that we pass in. That's not the same as, you know, iter.filter. That's one of the ones we passed in, and that's the point of this generic here. So we don't need to go back over that right now, but that was a fun one. Apply sectional is here. Apply previous iteration seems to be the main source of problem. So after this, it's got to be RNG and build data. So apply sectional needs new stuff. It needs the RNG and the build data. Why previous iteration? Closure is expected to take 2 arguments, but it takes 3. Where are we at? Hang on. We got rid of the E? I guess so. Or I put that there by accident. Yeah, this should only take 2. I don't know where the E came from. Whatever. Okay, apply sectional is good. What's next on there is room vaults. Apply yeah, we do still have 3 here. I kind of remember that, but I have to go take another look at where we removed that. I'm sorry. The refactoring is just brutal at times. So here it's going to be, I'm in the wrong one. Room vaults. And we're going to pull in this here. Now I see a potential issue. We're going to wait. Actually, this will be fine. That broke, so that warned me. If we're declaring an RNG somewhere, it warned me. That's good. No longer self.depth, right? So do we want to vault at all? Okay, it was just 2, but I was not sure and I was lazy. All right. Have just a little bit more. Our build function is no longer happy because we just need to pass in a bunch of extra stuff with it. Like so. This is build data on like every single one. Maybe an RNG. All right. Let mute RNG. Good, we don't have any in here. And that was that. That was a big, beefy one. That's the worst one. But it's over. And we're going to test our changes with like a lot of stuff now. So check this out. This is what we were doing before, but it's more, it's better. It's better now. So we start with the Voronoi. We waveform collapse it. We give it vaults with the prefab builder. We pick the center starting position. We call unreachable. We do Voronoi spawning. We add a sectional to it after we spawn. And that's fine. That'll remove the existing spawns, but it'll potentially put like the fort in, right? So we're putting an underground fort. So that'll have its own spawns, right? So we remove the existing ones in that area. We replace all those tiles with the fort, and then we add our exit. And let's see what it looks like. This is way better to test things as well, and I'll explain what I mean in a minute. So we see our Voronoi being built. Really fun, right? So before, if we wanted to build out a complex map like this, it was a lot of boxes. Box this with that, box, and it does get a little cumbersome, right? Even Snake would be annoyed by that many boxes. So now it's a lot easier to build out a complex map like this. And if I want to do something else, like, I don't want Voronoi, right? We don't like Voronoi anymore. We want a maze. New. So we want a maze, and we're going to do all the same stuff to it. We're going to probably fail to add vaults because there won't be enough empty space in the maze. But we will, we'll be able to do the Voronoi spawning, or the waveform on it, I mean. Actually, we're doing vaults after waveform. But yeah, this is interesting. We just took a maze and we shuffled it. It actually failed, which I'm not surprised. It didn't work out very well, but it's okay. I think it'd be nice to do call unreachable after the fort, because the fort doesn't really make sense at that point. But whatever, it's okay. You can call unreachable a second time if you want. Okay. With that, head back over to the text, where we're basically done, I think. So let's take a look. So this demonstrates the power of our approach. We're putting a lot of functionality together from small building blocks. In this example, we're starting with a map generated from Voronoi Builder in Pythagoras mode, modifying it with a waveform collapse builder run, which will rearrange the map like a jigsaw puzzle, modifying the map by placing vaults, modifying it by with area starting positions, indicating we'd like to start near the middle of the map, modifying the map to call unreachable areas, modifying the map to spawn entities using a Voronoi spawning method, modifying the map to add an underground fortress, again using the prefab builder, modifying the map to add an exit staircase in the most distant location. Now we're going to delete the map trait and bits from common. So let's do that real quick. Let's see. Now that we have the builder mechanism, there's some old code we can delete. So let's go back to common if I still have that open. We can delete remove unreachable and generate Voronoi. So both of these, because we just moved all the code. And we can also open map builders mod RS, so the main one we've been working in, and delete the map builder trait. Oh, I think we already did that. I already did that. And its implementation. Oh no, I'm in the wrong mod. Builder map, builder chain, map builder. Is anything mad? Doesn't look like it, no. So we're good. All right. And it says, as usual, we'd like to go back to having map generation be random. We're going to break the process up into 2 steps. We'll make a new function, random initial builder, that rolls a dice and picks the starting builder. This is the same code we've done before, so I'm going to copy it. I know you're not seeing the text, but it's okay right now. So we'll do random initial builder here, and this makes sense. This is what we've been doing before. We just roll a 1D whatever, a 1D 17 to do all of our possible initial builders, right? The text also says, rolls a dice that picks a starting builder. It also returns a Boolean indicating whether or not we picked an algorithm that provides room data. The basic function should look familiar, but we've got rid of all the box new calls from the constructors make boxes. We've got rid of all the box new calls. The constructors make boxes for us now. So there we go. Pretty simple. We're just returning that box that we get back for free. So it's a little cleaner here. We don't care about that. The rest is a pretty straightforward function. We roll dice, match on the result table, and return the builder and room information we picked. Now we modify random builder to use it. And this is basically the same stuff. Again, being a little lazy, but it's boilerplate that we've done many, many times before. So random builder should look familiar. It does a builder chain with a random initial builder, and it starts with the random starter. That's the random thing we got back. If it has rooms, we do room-based spawning and stairs and stuff. Otherwise, we do the area-based, the Voronoi spawning, all that fun stuff, right? We call unreachable. And we spawn a distant exit. And then we do a random dice to see if we want to do waveform collapse. We do another roll to see if we want to do a sectional fort, a fort. And then we always try to add vaults. So there we go. Oops, hit the wrong thing. So the text says basically the same. It should look familiar. It selects a random room using the function we just created. If the builder provides room data, we chain room-based spawner, stairs, starting positions, 3 important steps required for room data. And if it doesn't provide room information, we chain area starting position, call unreachable Voronoi spawning, and distant exit, the defaults we use to apply inside each builder. Then we roll a 3-sided die. If it comes up with 1, we do wave function collapse to rearrange the map. If we then roll a 20-sided, if it comes up with 1, we apply our underground fort prefab. Then we apply vault creation to the final map, given a chance for pre-made rooms to appear. And there we have it. This has been an enormous chapter, but we've accomplished a lot. We now have a consistent builder interface for chaining as many metamap modifiers as we want to our build chain. This should let us build the maps we want. Each builder now does just one task, so it's much more obvious where to go if you need to fix/debug them. Builders are no longer responsible for making other builders, so we've called a swath of code and moved the opportunity for bugs to creep into just one simple control flow. This sets the stage for the next chapter, which will look at more ways to use filters to modify your map. It's going to look ugly for a second, but bear with me. So the next chapter is going to be fun with layers. This will be Wednesday. Existing algorithms as meta builders, applying cellular automata as a meta builder. Oh, this is going to be interesting. Oh, that's sick. I like that. Okay. That's about all I need to see for now. We're digging out of that. Oh, that's cool. Okay, I'm ready for this. Rooms are built and then corridors. So it's going to be another refactor boy, but it's going to be cool. All right, enough of that. So let's take a quick look at the running code once or twice as I wrap up by saying thank you to anyone who showed up, whether you are lurking or chatting. I appreciate it. If you like, oh, that's a funky BSP interior. That is a really funky one. I hope it collapses. Nope. Yeah, but I appreciate you showing up. If you like these coding streams, if you like Dwarf Fortress, which I'm playing now, I just finished Star Ocean: The Divine Force. I play Genshin Impact every Sunday. I'm also playing Caves of Cud. I'll be starting up a new game on Saturday and Sunday day streams as well, since I just finished Star Ocean. So if you like any of that stuff, I do play all kinds of games. And you can also see these coding streams on Monday and Wednesday. Hit that follow button here on Twitch. You can leave the notifications on to see when I go live. You can also head on over to YouTube, where the streams go up 2 weeks after they are live here on Twitch. Or if you are watching this in the future on YouTube, congrats on being in the future. But while you're over there, I'd like if you do all the usual fun YouTube stuff, like, subscribe, notification bell, leave a comment. I do read and I typically respond to those comments, so I would appreciate that. Do those stairs stay here? No, they got, I see, okay. But yeah, I would appreciate, I do read and respond to comments, so I do appreciate those. So, failing the maze, I love it. Cool. So yeah, comments, all that good stuff. You can also follow me on Twitter, where I do tweet every time I go live. If you just want to see that, you can hit the notification bell there. I do tweet, occasional things, but not that much. It's mostly just me going live. And I've heard people in the past complain about Twitch notifications being delayed and unreliable, so it's an option. That about does it. I hope this map works. Maze one is not great. There we go. It's kind of cool, though. Voronoi, it's always fun. So it's cool. We're getting all the different maps now every time, as we should. And the game just got a lot spicier. I mean, it kind of has been, but it feels a lot better now. Now that, I mean, it is a better code. I hope this code made sense as to why this was good, why this was valuable. I like it. It was a beefy chapter, a lot of copying at a point, because I don't think it was necessary to check every single line at a point. Although you'd have to if you were doing it yourself, manually. If this were your game, you'd have to do that refactor. But it is what it is. So that is going to be it. So we'll get back next time with that layering and stuff. And I'll be back tomorrow with some Dwarf Fortress. Really excited about that. So until then, until next time, have a good day, have a good night, whatever it is, wherever you're at. Take it easy.
You must continue your mission.